Thank you very much. I'm not going to talk about Orion. That's my day job. Very exciting project, cooperation between Europe and USA. I'm representing the International here, one of them anyway, so it's exciting to talk here. Just a bit of a word about, Astrium North America, or Astrium. You've probably heard of the name change. I'll just quickly go over that. European Aeronautic Defence and Space Company has now changed all its operating entities to Airbus commercial aircraft, Airbus helicopters. We've been merged with space, with defence, so it's Airbus Defence and Space. If you're in the USA, that will be spelt with an S, like the French, but the Brits are with a C. So it's Airbus Defence and Space. I'm a bit disappointed that it wasn't Space and Defence, but I'm not at the pay grade to decide that. So we've just changed the names of all the companies now, so it's Airbus Defence and Space as of a couple of weeks ago. Transitioning to commercial space, this is the title of my talk. I really wanted to talk about, we've been involved in traditional business in Astrium or Airbus Defence and Space, typically space station, Columbus, development of that in Europe, automated transfer vehicles, supporting those missions, especially from our base in Houston, where our office of Astrium North America is. We've been trying to get more involved in commercial spaceflight. So we've been active since 1973 inside the United States with the oldest Astrium company here. Got a very small team, and basically we started off developing integrated cargo carriers for the space shuttle. So we've been doing that for quite a number of years, essentially I think about 12 years and over a dozen flights. And essentially we were developing this commercially, doing the mission integration commercially for a government customer. This is extremely successful, been a successful project. And of course now we're transitioning to this external payload platform, which I'll show you later, which is developed commercially for a commercial customer. There's a bottleneck at the moment in getting small objects to space, small payloads. We're going to offer a service which is going to use the ISS as a platform there, and we are offering services basically to expose payloads to microgravity externally from the Japanese module. And we want to do this commercially, and I think there's a great, benefit now because there's plenty of opportunities to get small payloads up there to the ISS, and we are currently taking orders for that. We're talking about a 12-month turnaround time from contract signature to launch, typically, and there's a lot of different vehicles that visit the ISS, so this could basically solve the bottleneck there, essentially. So you're looking at, you want to fly payloads there for Earth observation experiments, you want to test technologies out in space, retire the risk, things like this is a great opportunity. This really shouldn't be confused with the NanoSat initiative. We're working with NanoRacks as well. These experiments are attached to an external payload platform, which you can see on the left-hand corner there. Well, the beauty of this external payload platform is you don't need to do any EVAs to get out there. It saves on crew time in that sense. The NanoSat-sized test experiments are developed commercially. We accompany the process, basically do all the processing there. There's no peer reviews for that. This is purely commercial. We agree a price depending on the services that you need. Basically, it goes up in the spacecraft internally, goes onto this platform. You can see grappled inside the Japanese module, and then it's taken out in an airlock, and then you can see the robot arm there, which then grabs it and places it out there. So standard time, exposure time is 15 weeks. We can extend that depending on the particular customer. So the beauty of this is quite simple. You bring your small payloads up in the various visiting vehicles, and this really is going to be very, very efficient in that sense. So as you can see here, the 12 months from signature to launch with turnkey access. So you come to us and NanoRacks with your experimental idea. We discuss your specific needs. The chart there is not really to scale. I'm not too good at PowerPoint, so really the contract and the mission integration parts to the launch is about 12 months typically. That's where a lot of the bulk of the work is done up front. So you're talking to us about the experiment design, safety reviews, mission integration, things like this essentially. And then, of course, then you have the launch here on the various visiting vehicles, including Cygnus, Dragon, Sawyers, etc. So there's plenty of different vehicles to do that. Then you have it installed, basically the equipment inside the Japanese experimental module on our EPP. Then it's then put on this airlock in the Japanese module, is then moved outside and then basically put into the external platform there for the mission. You can supply power and stuff like that, and that'll be on the next chart that you'll see in a minute. And to say the beauty of this as well, you can actually have the payloads return. This is an optional service. So the great thing about this is, I've been working in ISS for a long time. The hope is to speed up the turnaround time here, and obviously the whole process. So you can see here again, we're going to accommodate these experiment packages on the bottom of this external payload platform. The big blue purple thing there is the grapple fixture for robotic arm. It's got Wi-Fi interface to transmit basically data from the experiments onto the space station and down to ground. So you can see the different power that's available, and you can see another view here essentially. So USB, so it's standard interfaces essentially for the different payloads. We're trying to make it as simple as possible for customers to come and approach us and I say, come and visit our stand. Hopefully the stand will have arrived. It got lost yesterday at the airport, but I think it should have arrived by now. So here, the power basically is limited to the heat rejection essentially there. But the experiments that you can see at the bottom, if you were really ambitious, you wanted to use all of the space, then you could purchase all the space. The standard interface here you can see is a 4U form factor, but of course you can have 1Us, you can have 3Us, you could buy the whole space essentially. So as long as you fit within that form factor. I say the external payload platform currently at the moment is just finalizing qualification tests and be launched later on this year up to the ISS. So it'll be launched in pieces essentially, assembled up there, and then we're open for business essentially. We've got quite a few customers now, and say working with NanoAxis is extremely successful. We've been very, very happy to do that. So you can see here an ideal situation, a lot of 4Us here up to 9. It's connected to this platform here with the standard interfaces. And then basically it's it's earth pointing, basically the payloads down at the bottom, so you can use them for a wide variety of aspects. If you want earth observation, if you want to test let's say, retire the risk on technical developments, you can obviously use this as a very, very good service. And as I mentioned before, the return option is extremely, extremely useful. Just a bit of a geography lesson for a Brit who's working for a Houston-based Airbus subsidiary. We have got a lot of Airbus subsidiaries around. We're based in Houston. I actually sit in Denver because I'm with the Orion team. But please, come to our stand, drop us an email or speak to me personally. I'd love to introduce you to, we've got a one-to-one mock-up of the external payload platform there. Very happy to show you about it. Thank you very much.